Okay, the next topic, we'll do a lot more examples of balancing chemical equations. The last topic we're covering here is concerns the weights of atoms and molecule weights. I use the word interchangeably with the word mass. The way we're going to introduce this is quite simple. We find the mass of a molecule simply by adding up the masses of the atoms contained in it. The masses are expressed in terms of atomic mass units, which is a very small unit. We're going to find in the next class, we're going to find a different way of expressing the same thing, but right now we just think of the masses of atoms as being expressed in units of in these very small atomic mass units. Well, the weight of a molecule, or alternatively what I'd call a formula unit, is quite simply done by adding up the masses I get from the periodic table. So what I call FW, that's the formula weight. That's also the weight of one molecule, the molecular weight of CO2. I look in the periodic table and I see that carbon is 12.01 atomic mass units, and oxygen is 16. There's one carbon and two oxygens. And so I add the together 12.01 plus 2 times 16, and the result is 44.01. So for magnesium chloride, here I'm talking about, there aren't molecules of magnesium chloride, but I'm talking about the weight of one formula unit, one magnesium atom, two chlorine atoms. And so I call that the formula weight. I look in the periodic table, and I won't demonstrate this for you, but you can do it yourself. Add the mass of one magnesium atom to the mass of two chlorine atoms, and I get a result of 95.21 atomic mass units. Here's a problem that we're going to want to be able to do, and that is calculating from the formula weights, determine the so-called percent composition of every element in a compound. So, for example, what's the mass percentage of carbon in CO2? So if I were to separate carbon into the elements that make it up, carbon and oxygen, what percentage of that total mass that I get would be carbon? Well, I can see that from the last page, the mass of a molecule of carbon was 44.01, and the one carbon contained, the mass of the CO2 was 44.01. The one carbon contained in it was 12.01 atomic mass units. So I just carry out that calculation. What I get for that calculation is 27.3%. If I want to calculate the amount of the percentage of oxygen, I see of that 44.01, 2 times 16. 16 is the mass of one oxygen atom. There are 2 of them. I get 32. Oops, not sure what happened there. I get 32. Let's see. 32 over 44.01 expressed as a percent. Or 72.7%. We'll do another example. We will calculate the percent hydrogen in this compound, this C2H6O, and that compound could be ethanol. Adding up the molecular weight, 2 carbons, 6 hydrogens, 1 oxygen from the periodic table, I get 46.01 atomic mass units. And then of this total, I see that 6 times 1.007, 1.007 is the atomic mass of hydrogen. 6 times that, or 6.042 atomic mass units, is due to hydrogen. Therefore, the percentage I get is simply what I get by dividing 6.042, the mass of the hydrogen in the molecule, divided by 46.06, the mass of the entire molecule in atomic mass units, and I get 13.12%.